This is the third section of chapter 2 on measures of location and spread, and this section is measures of spread. So what is a measure of spread? Well, a measure of spread tells us how spread out our data is by considering the difference between two measures of location. So the difference between these two quartiles, the upper quartile and the lower quartile, is what we call the interquartile range, IQR. So this is a measure of spread. Then the difference between two percentiles, where this is the larger percentile, is what we call the inter-percentile range. Now this could be any two percentiles, but quite often we work out the difference between P90 and P10. Now, why do we use these measures of spread? Why not just use the range? Well, these measures of spread exclude extreme values, and we normally expect extreme values to be either at the lower end of our data or at the upper end of our data. These extreme values are known as outliers, and the reason why we exclude these extreme values is because these measures of spread look at the middle part of our data. So I'll put that word middle in quotes, because if it's the interquartile range, we look at the middle 50% of our data, so the top 25%, and the bottom 25% gets excluded. That's where we'd normally expect to see outliers, extreme values. And with the percentiles, if we're doing P90 minus P10, then we're only going to be looking at the middle 80%, again excluding those parts of our data where we would expect to see these extreme values. Example 6, the table shows the masses in tons of 120 African elephants. And we've got our table there, or African bush elephants. Find estimates for, so we start off nice and easy, the range. So that'll just be our largest mass minus our smallest mass. So that's 6.5 minus 4.0. So we'll get 2.5 tons for the range. Part B, we want to find an estimate for the interquartile range. Now to do that, we need to estimate Q3 and Q1. So let's start with Q1. So we want to find the position of Q1. So that will be Q1 as a fraction times by the total frequency, 120. So the 30th value is where I'd find the position of Q1. Let's put our cumulative frequency in so we can see which column it's in. So 13 plus 23 is going to be 36, plus 31 is going to be 67, plus 34 is 101, then 120. So the 30th value I'm going to find in the second group here. So now I can use those values now to work out an estimate for Q1. So this is where I draw my diagram, like this, my little bar method. So Q1, which has a position of 30, this group goes from 4.5 to 5.0. Notice there are no gaps between the groups, so I can just write those numbers down. I don't need to add or subtract 0.5, and then here and here I'm going to put what the frequencies are. So this group starts at where the last one finishes, at position 13, and this group finishes at position 36. So I can turn that into an equation to solve. Q1 minus 4.5 over 5.0 minus 4.5 equals 30 minus 13 over 36 minus 13. So that will give me Q1 minus 4.5 over 0.5 equals 30 minus 13, which is 17, over 36 minus 13, which is 23. So Q1 will equal 17 over 23 times by 0.5 plus 4.5. Well, that gives 4.8695. I'll round that to three significant figures and give Q1 as 5.87, three significant figures. So the next thing that we need to do is to do the same for Q3. So Q3 is a fraction, is 3/4 times by the total frequency. So that's 90. So the 90th value is where I'd find Q3. Using my cumulative frequency, where do I find the 90th value? In this group here, because this goes up to the 101st value. So we will just highlight this column instead. Now I do my diagram, a little bar. So let's just put 90th value here. So my bar will be like this. Somewhere in between, I've got Q3, which is the 90th value. This group goes from 5.5 to 6. So 5.5 to 6. And its position, well, it goes from where the last one finishes, so that's the 67th to the 101st position, 101st position. So now we can write our equation, which is Q3 minus 5.5 over 6.0 minus 5.5 equals 90 minus 67 over 101 minus 67. So that's going to give us Q3 minus 5.5 over 0.5 equals 23 over 34. So Q3 is going to equal 23 over 34 times by 0.5 plus 5.5. So Q3 gives us 5.8382. I'll round that to three significant figures, so I'll have Q3 as 5.84. Now I want the interquartile range. So the interquartile range is Q3 minus Q1, my estimates. That's going to be 5.84 minus 4.87. And that gives me 0.97 tons. So there we go. That is my estimate for the interquartile range. Now part C, we want to find the inter-percentile range. So just like before, we will need to estimate what these things are. So P10, let's find its position. So that percentile as a fraction is 1 or 10 over 100, which is 1/10. 10 over 100 times by 120. So that gives us 12. So the 12th value is where I'm going to find the 10th percentile, P10, and I'll find the 12th value in this group. So let's just highlight that there. We'll draw our bar like this. So we have P10, which is the 12th position. That group goes from 4.0 to 4.5. And the positions, 13th here and first value there. Right, so now we can do our equation. So P10 minus 4.0 over 4.5 minus 4.0 equals 12 minus 1 over 13 minus 1. So we have P10 minus 4.0 equals, so we will have 11 over 12 here. Whoops, and I forgot to write down, this is going to be divided by 0.5. So P10 is this, 11 over 12 times by 0.5 plus 4.0. What do we get for P10? We get 4.4583 recurring. So we'll round this, three significant figures. So 4.46. And now we do the same for P90. P90 as a fraction is 90 over 100 times by 120. That's the 108th value. Where do I find the 108th value? So get rid of that. 108th value is going to be in this last group here, so we'll highlight that. Now I draw my bar with P90 in the middle, and it's 108th position. Values go from 6.0 to 6.5, and positions go from 101 to 120. Now my equation, P90 minus 6.0 over 6.5 minus 6.0 equals 108 minus 101 over 120 minus 101. So that gives us P90 minus 6.0 over 0.5 equals 108 minus 101 is 7 over 19. So from there we can say that P90 is equal to 7 over 19 times 0.5 plus 6, and that will give us P90 as 6.1842, and it carries on. So we'll round that to 3 significant figures. So you've got P90 as 6.18. So now for our inter-percentile range, P90 minus P10, which will be that 4.46, the other way around, 6.18 minus 4.46 gives us 1.72, and its units are tons, 1.72 tons. So you should now be able to do exercise 2D on page 29.